Okay, so we're going to learn how to find the sine and cosine of trig functions without a calculator, but I'm going to prove to you that the answers work on a calculator. So this is the unit circle, and there's going to be 17 popular angles that you would learn next year in trigonometry. And these are 4 of them, or really 5, because 0, 90, 180, I guess it's right there, 270, and all the way back around is 360. So if they asked you what the sine or cosine is, you're going to label this 1, 0 on the unit circle, because this is a circle. This is called 0, 1. This is a negative 1, 0, and this right there is 0, negative 1. If they asked you the ordered pair xy right here is the cosine and the sine of those angles. So, watch carefully. If I asked you what the sine of 90, because pi over 2 is 90, if I asked you what the sine of 90 degrees is, all you say is, you make a quick little picture like this. You have to know how to make this picture on your own for the test. I know it's up there, but I'm just showing you how to make it. You put a dot here, a dot here, a dot here, a dot here, and it looks like that. I think you can make one of those really quickly. The sine at 90 degrees, it goes in alphabetical order. We're only learning cosine and sine. The cosine is the first number, the sine is the second number. So if I ask you what the sine of 90 degrees is, you look at 90 degrees, and the sine is the second number, right? So what's the sine at 90 degrees? 1, right? So let's do another one. If I asked you what the cosine of pi is the same thing as 180 degrees. The cosine at 180 degrees, cosine is the first number, or the x value. This is 180 degrees right here, right? The cosine is the first number. What's the cosine at 180 degrees? A negative 1. Okay, let's do another one. Let's do the sine of 270 degrees. Let's do the sine of 270 degrees. You're going to make a little picture like this, and you're going to look at where 270 degrees is. It's right here, it's 270 degrees. Sine is the second one because it goes in alphabetical order, cosine and sine. Sine of 270 is a negative 1. One more because we're having so much fun. Let's do the cosine of 90. Cosine of 90 degrees. What's the cosine of 90 degrees? 0 to 0. This is a quick way to figure out answers without a calculator, because when you get to the calculus level, you can't use a calculator. Okay, if you don't believe me, take your calculators out really quick. And let's do the sine of 90 degrees. Everybody hit sine and hit 90 degrees. The sine of 90 degrees, what does it say on your calculator? 1. Are they right? Okay, let's do the cosine of 180. Cosine of 180. Are we right? Negative 1? There's a reason why you have to know how to do this without a calculator. Like I said, in calculus, if you get there, you can't use a calculator. You need to know how to do these the long way. Okay, now it's going to get a little bit harder. Okay, now, these are the popular 17 angles that you're going to study for a whole semester. These are the popular angles that you would study next year. You notice that like 110 degrees isn't up there, 92 degrees isn't up there, 83 degrees isn't up there. These are the only angles that we would study next year in trigonometry. You just get really good at this. We just learned about 0, 90, 180, 270, and 360, didn't we? We learned how to find the sine and cosine of those 4 for 5, right? Now we're going to learn how to find the sine and cosine for what? All the other ones. So, the key to learning these is geometry. And I hope you remember this from geometry. There are two triangles that you should have learned, right? The 45, 45, 90. You guys remember that from geometry? 45, 45, 90. And the 30, 60. This is 30. This is 60. And this is 90. These two will get you these other angles. And you need to memorize these. I don't think it's too hard to memorize two triangles. Let's do the one over on the right side first. That's an isosceles triangle, right? Because it's 45, 45, 90. It goes 1 and 1. The two sides have to be equal if it's an isosceles triangle. And if you do a squared plus b squared equals c squared, it's the square root of 2. So every 45, 45, 90 triangle goes 1, 1, square root of 2. So far, so good. And then some of you already know how a 30, 60, 90 works because you had geometry last year. Opposite of 30 is a 1. Opposite of 60 is a square root of 3. And the hypotenuse on a 30, 60, 90 triangle is a 2. And you have to memorize these two triangles over the weekend. Is it hard to memorize these two? Not like other classes where you have to memorize a lot of stuff. It's only two triangles. Again, it goes 1, 1, square root of 2 for that one. Opposite of 30 is the 1. Most of you know that the smallest angle has to have the smallest side attached to it. Is 30 the smallest angle? Is 1 the smallest side? If you plug the square root of 3 into your calculator, you're going to get 1.7. Is that in between 60 and, or in between 30 and 90? Is 60 the next biggest number? And then it's 2 the biggest number, which would be across from the biggest angle, which is 90 degrees. So is that easy to memorize? The hypotenuse on both of them have a 2 in common. That's an easy way to remember. But one is the square root of 2 and the other one is at full 2, right? So, okay, one more before we leave this page. 45, 45 goes 1, 1, square root of 2. And a 30, 60, 90 goes 2, 1, square root of 3. So far, so good. Okay, now, how do we do these other ones? Before we do the other ones, you need to know what a reference angle is. You have to know what a reference angle is. So, all you do, this is really important that you watch this, is you draw 150 degrees out. And everybody knows it's right here, right? That's what we learned yesterday and how to graph 150 degrees, isn't it right there? Okay, now comes the next part. You take this and you bring it down to the x-axis so it makes a triangle. Okay, everybody listening, you never bring it to the y-axis. This could also make a triangle, couldn't it? But we're not doing that. All of them will always go to the what axis? The x-axis. Okay, now comes the reference angle. This angle next to the origin of this triangle is called the reference angle. It's always positive. Does it say that up there somewhere? Yeah. Oh, it's always positive. So, if you went 150 degrees to here, and this is a straight line, how many degrees would have to be in there? 30 degrees. Everybody got that? If you already went 150 degrees, and this is a straight line, that angle in there needs to be 30. I need you to put 30 degrees in there. And now we're going to label the sides of this triangle. This is the 90 degrees, this is the 60 degrees. A 30, 60, 90 triangle. But now, it's something you've never done at the geometry level. What I showed you on the last page is this. These are called floating triangles. That's what you learned in geometry. These are always positive, correct? Because it's a floating triangle. What we learn in trigonometry is everything is on the xy coordinate plane. If you go in this direction, isn't it positive? If you go up, isn't this positive? So everything in here is positive, correct? If you go over here, don't you go negative and positive? Don't you go negative and negative? Don't you go positive and negative? So if I fill this in, Opposite of 60. Do you know what the number is opposite of 60? What's the number opposite of 60 degrees? Square root of 3. But it's not the square root of 3. It's a negative square root of 3. Because I went to the left to get there, right? It's a negative square root of 3. This side is going to be positive because I'm going up. And what's the opposite of 30? 1. And it's a positive 1. But the hypotenuse is always positive. This one's always a positive. These two could change signs depending on which quadrant you're in. But okay, now we're going to do the cosine and the sine of this picture, and that's all we're really learning today. But we're going to do a whole bunch of these so that you get better and better and better and better at this. Isn't the cosine cos A over the H, the adjacent over the hypotenuse? And isn't the sine opposite over hypotenuse? Correct? And what angle are we going to look at? The angle next to the origin. That's what's the one, the reference angle. So let's do cosine first. What's the side next to 30 degrees? Isn't it a negative square root of 3? Over the hypotenuse. 2. Done. What's the sine? What's the opposite of 30? Opposite of 30 is 1 over 2. Final answer. This is all we're doing today, but we're going to end up doing a bunch of these. Because some of you understand this, most of you don't understand this, because this is what trigonometry is all about next year. Let's do another one. So the first thing you do is graph 225, right? Like yesterday, isn't it down here, 225? Okay, here's the question. We need to make a triangle, right? Do I bring this little tip to the y-axis, or do I bring this little tip to the x-axis? To the x-axis. So far, so good. First step, right? Make a triangle. The next step is called the reference angle. The reference angle is always the angle, obviously this is a 90-degree one, right? The reference angle is always this one in here. It's always the one next to the origin. We need to figure out what that reference angle is, right? It's always positive. And basically, you have to think, if this is 180 degrees right here, correct? Didn't I go past 180 degrees a little bit? How much past did we go 180 degrees past? 45 degrees. You guys can handle figuring out how much past 100 marker. This angle right here is 45 degrees. And if that's 45 and that's 90, isn't this also 45 degrees? So isn't this the other popular triangle that you need to know, the 45, 45, 90? Again, how many triangles do you need to learn? 2. Is it that hard to learn 2 triangles? You know if it's 45, 45, the two sides are the same. They're ones. But they're not ones because of the quadrant you're in. In order to get to this little point right here, I have to go negative, negative. Everybody see in this triangle? So that's why this is a negative 1. That's why this is a negative 1. And every hypotenuse on a 45, 45 is the square root of 2. This is always positive. It's never negative. Now that you have your picture done, all they want you to do is find the cosine and the sine. And I like writing the A and the O. You don't have to. Most of you know the A and the O. So you're looking at the triangle. I'm going to go nice and slow. We're always looking at the one next to the origin, and you need to come up with the side adjacent to that angle. The side adjacent is a negative 1 over the hypotenuse, which is the square root of 2. And then you do the O. The side opposite of that is a negative 1 over the hypotenuse, square root of 2. But there's a rule in math, I think most of you know the rule in math, that you can never leave a what in the denominator? The square root, the radical. So can't you multiply the top and the bottom by the square root of 2? So what do they want as your final answer? A negative square root of 2 on the top, because I multiplied the top and the bottom by the square root of 2. What's the square root of 2 times the square root of 2? 2. And then same thing for this one. Final answer. Your calculator won't give you that answer because your calculator only rounds the answer to 8 decimal places, whatever your calculator. This is way more accurate than a calculator. Okay, do we have any more on this page? Did we really? Did we really?
Yeah. I like your email the best.
Did you really? You really like my email?
Hey, whatever.
She liked my email. I told her what a wonderful person she was and how she grew as a person through the years and how quiet she was at the beginning of her career in my room and how more outspoken and positive and happy-go-lucky. Yep, come again. Oh no, I'm on.
Yeah, I was going to say, I like for the recording.
Okay, back to our notes. We just won donuts. Sorry you guys weren't here to get them, but we ate them for you. Okay, moving on. A negative pi over 3. If you don't remember, let's just quickly change this into degrees because it's been a while since, isn't it 180 over 5? You guys remember that from yesterday? How do I know? I already know the answer. I think that's 2, but we're going to figure out how many degrees this is. The pi's go away. 3 goes into 180 exactly 60 times. So the same thing as a negative pi over 3 is a negative 60 degrees. So they might give it to you in radians. I don't think I do, but I'm just showing you how to change it back into degrees. Where is a negative 60? You have to go down instead of up. Everybody see that? So the first thing I do is I graph the negative 60, which would put you in this quadrant. So far, so good. Okay, look at that. The tip of my little arrow, it'd be way easier to get it over to the y-axis, wouldn't it? It'd be way easier, wouldn't it? But are we going to go to the y-axis? Nope. We're going to take that tip and bring it to the x-axis. This is the 90 degrees. Most of you know what the reference angle is. It's always positive though, even though you want to say it's the negative. Angles are always positive in math, right? You've never heard of a negative angle in a triangle. Have you ever heard of a negative angle? So, we're trying to figure out how many degrees is that little spot right there next to the origin, and I think most of you know what that angle is. Even though we grafted a negative 60 degrees to here, this angle in here is a positive 60 degrees. It's always positive. This is always positive. Even though we grafted a negative 60, we ignore it. Because whenever you make a triangle, you have never heard of a negative 60 degrees. It doesn't even make sense. And if that's 60 and that's 90, this little guy right here needs to be 30. And if you have your triangles memorized, the rest of it should go pretty smoothly. If you're in this quadrant, you need to go to the right positive and down. Everybody understand that? So this is positive, and this is going to be negative. So let's see. Opposite of 30 is a positive 1. Most of you know that? Opposite of 60 is a negative square root of 3. And on a 30, 60, 90 triangle, the hypotenuse is a positive 2. And then all you have to do is do the cosine of the picture and the sine of the picture. And I'll put the A and the H and the O and the H one more time. Okay, again, you always are looking at the 60 degrees one, and you're trying to find the side adjacent to that picture. Most of you know which one is adjacent to that picture. 1. And everybody knows the hypotenuse is 2. 1 over 2. And an opposite of 60 is a negative square root of 3 over the hypotenuse, 2. Final answer. The 45, 45, 90 is the tricky one because that's the one that has the hypotenuse of the square root of 2 and you can't leave it in the denominator, right? Okay, I think we don't need to see that. Now it's practice for part 1. So here's part 1, finally. This is what you're going to see on your worksheet. The only part that you're doing in part 1 is can we find reference angles? Can we find reference angles? So all you're going to do is draw little pictures for part 1. How many are there? 2? So part 1 on the worksheet, we're just going to learn how to find a reference angle. first thing you're going to do is draw 110 like you did yesterday, right? And I start here and I'm cruising and I'm cruising and I'm cruising and I'm cruising and I stop about right here. I might have went a little too far, but that's about 110 degrees. So far, so good. The next thing I'm going to do is I'm going to drop it to the x-axis. The next thing I'm going to do is I'm going to find my reference angle and I'm going to fill it in right there. Right here is my reference angle. If I already went 110 and a straight line makes 180, what does that angle need to be right there? 70. 110 plus 70 is 180. Yeah. Are they asking you to find the sine and the cosine? Do we have to label any sides of the triangle? We can't, because this is not the popular 30-60, this is not the popular 45. We don't know how to label it anyway, right? You are done with your problem. That's all I want you to do for the first part of the assignment. Do one more.
So they're not going to be like that normal time, or
It will be in the second part when I ask you to do the sine and cosine.
like for the one okay.
Up here, they're going to be any angle you want it to be in part one. So let's do one more. 250, we're cruising, and are we passing the 180 marker, you guys? And isn't 270 right here? So don't I have to hold up a little bit? Isn't it about right there? About right there. Oh, it should be so easy to draw that to the y-axis, wouldn't it? But no, you gotta stop yourself, and you're gonna say, no way, I can't bring it to the y-axis. I need to bring it to the x-axis. And you have to figure out, this angle is called the reference angle. It's always positive, and it's a very important angle in trigonometry. Let's see, how much past the 180 marker did I go? How much past the 180 marker did I go to get to that spot? What is that? 70 also. That one's also 70, right? Okay, one more because we're having fun. Let's do this one. Let's do 310. Let's do 310 degrees. I kind of want to do one in every quadrant, so 310. I'm cruising and I passed the 270 marker by, I don't know, like about right there. I passed the 270 marker to about right there. It's about 310. Again, always bring it to the what axis? X-axis. Okay, this angle right here is called the reference angle, and let's see how you think you come up with this reference angle. If this is 310 to here, isn't the rest of this make 360? Doesn't the rest of it make 360? So isn't this the rest of it, this angle? Doesn't that make the rest of a full circle? Does that make sense? So how much past, or what would this, if you already went 310 and a full circle makes 360, how much would that angle have to be in there? 50. Yep, that angle would have to be 50. It's very important in math to know how to find reference angles. And I did one in every quadrant except the first one. Here's the first one. 20 degrees. Where is 20 degrees? Does that look like about 20 degrees to you, you guys? Do you drop it to the x-axis? Wow. How many degrees is that right there? 20. It's a no-brainer in the first quadrant, right? It's a no-brainer in the first quadrant. You got to do some thinking in these three quadrants. Good? Okay, now the second part. Yeah. Good. So everybody knows on the first part you're only finding the reference angle. Good? What's your question? Nothing? Okay, so this is 20 degrees right there. Can't write it in there because it's so little. But okay, now comes the second part. Find the sine and cosine. Did we already do 225? Let's make this 120. So step number one, graph 120, and then I'll be done. Graph 120. Here's 120. Draw to the x-axis. This is 60. Most people know that it's 60 if you went 120, right? Opposite of 60 is a square root of 3. Opposite of 30 is going to be a negative 1 because you went to the left and up. Everybody see why they're negative and positive? And opposite of this is a 2. And then all you do is find sine and cosine. I don't even know. I think I just wrote those in the wrong order, but that's okay. Cosine is the side adjacent over the hypotenuse. Sine is opposite over the hypotenuse. That's it. One more. Let's see if you remember. Let's see how good your let's do 180 degrees. 180 degrees. Graph 180 degrees. You see where it is? It's right on the line. Does it make a triangle, you guys? Does it make a triangle? No. We have to go all the way back to the beginning of our lesson. Do you remember what the beginning of the lesson looked like? If it lands, sometimes it lands right on the unit circle. Sometimes 0, 90, 180, 270. 180 is a negative 1 comma 0, right? So, wait, we're almost, where it's right here. This is a negative 1 comma 0. And they're asking you to find the cosine and the sine. Do you guys remember how to find the cosine and the sine when it doesn't make a triangle? The cosine is, yep, first number, and the sine is the second number. So, we learned all of the degrees. Are we done? Or, I don't think, I have more, but we could keep going. But they're all the same. Yep.
Is this gonna be on, like online today?
Yeah. Yeah.
We got donuts, Jimmy.